Close your eyes and imagine yourself slowly sinking beneath the surface of a calm ocean, leaving behind the world of sunlight and sound. As you descend, the familiar blue of shallow waters gradually deepens, like watercolors bleeding into darker hues on an artist's canvas. This is your gentle journey into one of Earth's most mysterious realms, the deep sea, where life has learned to thrive in ways that would seem impossible to us surface dwellers. In the first 100 meters, sunlight still dances through the water, creating those mesmerizing patterns we remember from peaceful swims. Fish dart about in silver schools, and the water feels warm and welcoming. But as you continue your descent, something magical begins to happen. The light grows softer, more diffused, like the gentle dimming of lights in a theater before a profound performance begins. By the time you reach 200 meters, you've entered what scientists call the twilight zone, the mesopelagic realm. Here, the last whispers of sunlight create an ethereal blue-gray world that exists in perpetual dusk. It's neither day nor night, but something beautifully in between, like those peaceful moments just before sleep when the world grows quiet and still. The water temperature begins to drop, and you might notice how the pressure around you increases with each meter. Though the change is so gradual, it feels like being gently embraced by the ocean itself. As you sink deeper, past 1,000 meters, you cross an invisible threshold into the bathypelagic zone, the midnight realm where no sunlight has ever reached. The darkness here is complete and absolute, more profound than any night on land. Yet, this isn't a lifeless void. It's a world pulsing with its own gentle rhythms, where creatures have evolved their own sources of light and their own ways of finding food, shelter, and companionship in the endless night. The pressure at this depth is extraordinary. Imagine carrying the weight of a small car on every square inch of your body. Yet the creatures here move with the same graceful ease as birds floating on air currents. They have adapted to this crushing embrace over millions of years, their bodies becoming living testimonies to life's incredible ability to find a way, even in the most challenging circumstances. Deeper still, past 4,000 meters, you enter the abyssal plains, vast underwater deserts of fine sediment that stretch for thousands of miles. The water here is just above freezing, and the pressure is now hundreds of times what we experience at sea level. It's a world of profound stillness, where a single grain of marine snow, the gentle rain of organic matter from the surface, might drift for hours before settling onto the sea floor, like a tiny gift from the world above. This descent into the deep is more than just a journey through water. It's a voyage through time itself. The deeper you go, the more ancient and primordial the world becomes. Here, in the deepest trenches that plunge over 11,000 meters below the surface, you find yourself in an environment that hasn't changed much since the early days of our planet. It's a place where life moves slowly, conserves energy carefully, and has learned the art of patience that we, surface dwellers, might envy. The beauty of this descent lies not just in its physical reality, but in what it represents about life's determination to flourish. Every meter deeper reveals new adaptations, new solutions to seemingly impossible problems, new ways of creating light in darkness, warmth in cold, and community in isolation. As you drift deeper into this liquid space, you're witnessing evolution's most creative solutions, painted across millions of years in living form. In this gentle journey downward, we begin to understand that the deep sea isn't just Earth's basement, it's perhaps its most innovative laboratory, where life has spent countless ages perfecting the art of survival in conditions that would challenge our wildest imagination. Here, in the crushing depths, we find not harsh struggle, but elegant adaptation. Not desperate survival, but graceful existence in harmony with forces beyond our everyday experience. Living light, the poetry of bioluminescence in the abyss. In the profound darkness of the deep ocean, where no trace of sunlight has touched for millions of years, something magical happens. Life itself becomes light. Imagine floating in this liquid space, surrounded by what appears to be complete emptiness, when suddenly a gentle blue glow appears in the distance, soft as moonlight, ethereal as a distant star, yet alive and purposeful in ways that starlight could never be. This is bioluminescence, one of nature's most enchanting gifts, and in the deep sea it becomes not just a curiosity but a necessity, a language, and an art form, all woven together into the fabric of survival. Nearly 90% of all creatures living below 1,000 meters have evolved the ability to create their own light, transforming the midnight zone into a living constellation of blues, greens, and the occasional warm amber glow. Consider the delicate moon jelly, drifting through the water column like a living chandelier. When disturbed, it pulses with rings of blue light that cascade across its translucent bell, creating patterns that seem choreographed by some cosmic designer. This isn't merely beautiful, it's functional. The sudden flash of light startles predators, giving the jellyfish those crucial seconds needed to pulse away into the safety of darkness. Yet watching this display unfold is like witnessing poetry written in light across the liquid page of the deep ocean. The deep-sea anglerfish has perhaps perfected this art most famously. Picture a creature no larger than your hand, hanging motionless in the water, its bioluminescent lure glowing like a tiny lantern in the vast darkness. This isn't just any light. It's produced by symbiotic bacteria living in a specialized organ called a photophore, creating a partnership between two completely different forms of life. The bacteria receive shelter and nutrients, while the anglerfish gets its fishing rod of light, dangling it like a patient angler waiting for the perfect moment. But the anglerfish's light serves multiple purposes beyond hunting. Different species have evolved different patterns of photophores along their bodies. Some have lights arranged like windows on a midnight cruise ship. Others sport patterns that look like constellations mapped across their sides. These patterns help them recognize their own species in the darkness, a gentle form of deep-sea social networking that allows them to find mates in an environment where encountering another creature is already an extraordinary event. Perhaps even more mesmerizing are the siphonophores, colonial creatures that can stretch longer than a blue whale, yet remain as delicate as spun glass. They drift through the deep ocean like living necklaces of light, each individual organism in the colony contributing to a coordinated display that can span hundreds of feet. When threatened, the entire colony can flash in unison, creating waves of blue-green light that ripple along its length like a slow-motion lightning bolt made of stars. The vampire squid, despite its ominous name, is actually one of the ocean's most gentle light artists. When threatened, it turns itself inside out, revealing photophores that create a spectacular display, points of light scattered across its body like a living firework frozen in time. This transformation is so complete that it changes from a recognizable squid into something that looks like an alien flower blooming in the darkness, beautiful enough to confuse predators who might not recognize this glowing apparition as potential prey. Tiny copepods, minuscule crustaceans smaller than rice grains, create some of the most spectacular light shows in the deep ocean. When disturbed by a passing whale or submarine, millions of these creatures can flash simultaneously, creating what researchers describe as underwater auroras. These living light displays can stretch for miles, pulsing and flowing like the northern lights, but underwater and made entirely of living creatures responding to the rhythm of the sea. The lanternfish takes a different approach to bioluminescence, using it for camouflage in a technique called counter-illumination. These small silver fish have photophores arranged along their bellies that they can adjust to match the faint light filtering down from above. To a predator looking up from below, the lanternfish essentially disappears, becoming invisible against the slight glow from the surface far above. It's nature's version of active camouflage, requiring the fish to constantly adjust its light output as it moves through different depths, like a living dimmer switch responding to the subtle changes in its liquid environment. What makes deep-sea bioluminescence so particularly soothing to contemplate is its efficiency and gentleness. These creatures create light without heat, without waste, without the harsh intensity we associate with artificial illumination. Their light is cool, soft, and purposeful, more like the gentle glow of fireflies on a summer evening than the blazing intensity of the sun. It's light designed not to conquer darkness, but to communicate within it, to navigate through it, to create beauty and function in perfect harmony. In this realm, where every calorie must be carefully conserved, every flash of light represents a significant investment of energy. Yet these creatures continue to illuminate their world with displays of such beauty that they remind us that even in the most challenging environments, life finds ways not just to survive, but to create moments of wonder and grace that speak to something deep within our own understanding of what it means to be alive. Masters of pressure, how life adapts to the deep's crushing embrace. Picture yourself holding a marshmallow at sea level, soft and airy, full of tiny pockets of space. Now, imagine taking that same marshmallow and slowly descending to the deepest parts of the ocean, where the pressure is over 1,000 times greater than what we experience on land. The marshmallow would compress into something no larger than a small pebble, its structure completely transformed by forces beyond our everyday comprehension. Yet, in these same crushing depths, creatures not only survive, but thrive with an elegance that seems to mock the very forces that would destroy us, surface dwellers. The secret to deep-sea survival begins with a fundamental reimagining of what a body can be. While we, land creatures, are filled with air spaces, our lungs, our sinuses, the spaces between our cells, deep-sea animals have evolved bodies that are essentially incompressible. Their tissues are filled with water and specialized proteins that don't collapse under pressure, but instead maintain their shape and function like flexible, living sculptures designed by millions of years of patient engineering. Consider the barrel-eye fish, a creature so perfectly adapted to its environment that it seems to exist in a state of perpetual zen. Its head is completely transparent, filled with a clear gel-like substance that protects its tubular eyes while remaining perfectly stable under crushing pressure. These eyes can rotate upward within the transparent head, allowing the fish to look through its own skull to spot the silhouettes of prey swimming overhead. It's an adaptation so elegant and unusual that when scientists first discovered preserved specimens, they couldn't understand how the fish could possibly see. The transparent head had collapsed during the journey to the surface, hiding this remarkable feature from view. The deep-sea gigantism we observe in many abyssal creatures is another beautiful response to pressure and cold. Giant tube worms, some stretching 8 feet long, sway gently in the currents around hydrothermal vents like living wheat in an underwater field. Their size isn't accidental. Larger bodies are more efficient in cold water, losing heat more slowly and requiring less energy to maintain basic functions. These creatures have essentially become living thermostats, perfectly calibrated to extract maximum efficiency from every calorie in an environment where food is scarce and precious.
Deep-sea fish have solved the pressure problem in ways that would make engineers weep with admiration. Their swim bladders, the gas-filled organs that help shallow water fish control their buoyancy, are either completely absent or filled with specialized fats instead of gas. These fats remain liquid even under extreme pressure and cold, allowing the fish to maintain neutral buoyancy without the risk of compression that would doom a gas-filled organ. It's like replacing a balloon with a perfectly weighted liquid that maintains its volume regardless of the forces pressing against it. The proteins in deep-sea creatures tell perhaps the most remarkable story of adaptation. Normal proteins would unfold and cease to function under the extreme pressure of the deep ocean, like delicate origami sculptures being slowly crushed. But deep-sea proteins have evolved additional chemical bonds and structural modifications that actually make them more stable under pressure. Some of these proteins work better under crushing conditions than they would at the surface. They've been so perfectly adapted to their environment that bringing them to shallow water would actually impair their function. Temperature adaptation in the deep sea requires its own set of elegant solutions. In water that hovers just above freezing year-round, chemical reactions slow to a crawl, and metabolism must be carefully managed to avoid energy waste. Deep-sea creatures have responded by developing slower metabolisms that burn fuel with extraordinary efficiency. A deep-sea fish might eat a meal and then remain perfectly still for weeks, slowly digesting and extracting every possible nutrient, like a living meditation on patience and conservation. The Dumbo octopus, with its adorable ear-like fins, represents perhaps the most charming adaptation to deep-sea life. These creatures pulse through the water with movements so slow and deliberate, they seem to be practicing underwater Tai Chi. Their bodies are gelatinous and soft, offering no resistance to the crushing pressure while maintaining perfect control over their movements. They've traded the muscular athleticism of their shallow water cousins for a different kind of grace, one perfectly suited to a world where every movement must be calculated and every expenditure of energy carefully considered. Perhaps most remarkably, many deep-sea creatures have evolved what scientists call pressure-sensing organs, specialized structures that can detect
minute changes in water pressure. These allow them to navigate the subtle pressure variations that exist even in the deep ocean, riding invisible currents and detecting the movements of other creatures from remarkable distances. It's like having a sixth sense perfectly attuned to the liquid environment around them, allowing them to move through their three-dimensional world with a precision that borders on the supernatural. The reproductive strategies of deep-sea creatures also reflect the challenges of their high-pressure environment. Many species have evolved to release floating eggs that drift slowly upward toward areas of slightly lower pressure, where development can proceed more easily. Others have developed elaborate mating displays using bioluminescence, ensuring that when two creatures do find each other in the vast darkness, they can recognize their own species and successfully reproduce despite the crushing environment around them. What emerges from studying these pressure adaptations is a profound appreciation for life's ability to find not just survival, but elegance and beauty in the most challenging circumstances. These creatures haven't simply endured the crushing depths, they've embraced them, turning what would be a hostile environment for surface dwellers into a perfectly calibrated home where every adaptation serves multiple purposes and every structure reflects millions of years of evolutionary refinement. In the gentle rhythm of deep-sea life, we find a different way of being, one that values efficiency over speed, patience over urgency, and perfect adaptation over brute force. These masters of pressure remind us that there are many ways to thrive in this world, and sometimes the most profound success comes from learning to work in harmony with forces that initially seem impossible to overcome. Underwater volcanoes and coral forests, oases of life in the abyss. In the vast cold darkness of the deep ocean floor, where temperatures hover just above freezing and the pressure could crush a submarine, something extraordinary happens. The earth itself becomes a gentle gardener, tending oases of warmth and life through underwater volcanoes and ancient coral forests that transform the barren seafloor into thriving communities more diverse than tropical rainforests. Imagine walking across an endless plain of fine sediment, stretching in all directions like a moonlit desert beneath miles of water. The silence is profound, broken only by the occasional gentle current stirring the soft mud that has been accumulating grain by grain for millions of years. Then, in the distance, you notice something that seems impossible. A glow on the horizon, warm and inviting, like the light from a cozy cabin window on a winter night. This is your first glimpse of a hydrothermal vent, one of the ocean's most remarkable phenomena. These underwater hot springs emerge where the Earth's crust is thin, allowing seawater to seep down toward the planet's molten interior. The water heats up, sometimes reaching temperatures of over 750 degrees Fahrenheit, and becomes charged with minerals dissolved from the surrounding rock. When this superheated, mineral-rich water meets the frigid ocean, it creates something that looks like underwater smoke, billowing plumes of dark, mineral-laden water that rise like gentle spirits from the sea floor. Around these vents, the ocean floor transforms into something resembling an alien garden. Towering mineral chimneys grow slowly over years, built layer by layer as the hot water deposits copper, zinc, and sulfur compounds. Some of these chimneys stretch 30 feet high, creating underwater skyscrapers that serve as apartment buildings for countless creatures. The chimneys themselves are living sculptures, constantly growing and changing as the minerals precipitate out of the flowing water, creating formations that look like underwater versions of the fairy chimneys found in Turkey's Cappadocia region. But the real magic happens in the warm water surrounding these vents. Here, in a zone where temperatures might range from pleasantly warm to merely cool, instead of near freezing, life explodes in abundance. Giant tube worms, some as thick as a person's arm and 8 feet long, sway gently in the current like underwater redwoods. Their bright red plumes filter nutrients from the water, while their bodies house billions of bacteria that help them process the chemicals flowing from the vents. These vent communities operate on a completely different energy system than the rest of the ocean. While most deep-sea life depends ultimately on the rain of organic matter from the surface, those tiny particles of marine snow that drift down like a gentle, constant snowfall, vent communities are powered by the Earth itself. They represent life's ability to find energy in the most unexpected places, turning the planet's own heat and chemistry into the foundation for entire ecosystems. The diversity around these vents rivals that of coral reefs, yet exists in conditions that would seem utterly hostile to life. Ghostly white crabs scuttle across fields of mineral deposits, their shells adapted to resist the acidic conditions created by the vent chemistry. Scale worms, covered in metallic-looking scales that shimmer in the dim light of research submersibles, graze on bacterial mats that coat the warm rocks like living carpets. Perhaps even more remarkable are the cold seeps, areas where hydrocarbons and other chemicals slowly leak from the seafloor over periods of decades or centuries. These create more gentle, longer-lasting oases where life can establish itself with the patience of a master gardener. Cold seep communities often feature massive clams, some over a foot long, that can live for centuries. These ancient mollusks sit quietly in the sediment, filtering the chemical-rich water and growing so slowly that individual clams become living libraries of deep-sea history. In the Pacific Ocean, ancient deep-sea coral forests create underwater cathedrals that rival any terrestrial forest in their quiet majesty. These cold water corals don't depend on sunlight like their shallow water cousins. Instead, they filter nutrients directly from the water, building their calcium carbonate skeletons, one tiny polyp at a time, over hundreds or thousands of years. The resulting formations are breathtakingly beautiful, branching structures that look like underwater trees, their branches providing shelter and hunting grounds for fish, crabs, and countless smaller creatures. These deep-sea coral gardens grow with the patience of mountains, adding perhaps a few millimeters each year to structures that may be older than human civilization. Some of the largest deep-sea coral formations are thousands of years old, having grown slowly and steadily through ice ages and warm periods, through the rise and fall of human empires, creating underwater monuments to life's persistence and patience. The Lophelia pertusa coral, one of the most common deep-sea reef builders, creates formations that can be seen from space when they grow large enough. These reefs provide critical habitat for deep-sea fish, serving as nurseries where young fish can find shelter and abundant food. The three-dimensional structure of the coral creates countless niches and microhabitats, turning what would otherwise be a flat, featureless seafloor into a complex underwater landscape. What makes these underwater oases so particularly fascinating is how they demonstrate life's ability to create abundance from scarcity. In an environment where food is limited and energy is precious, these communities have found ways to support incredible diversity and biomass. They remind us that life doesn't simply adapt to existing conditions. It actively transforms its environment, creating new possibilities and new forms of beauty. The gentle currents that flow around these underwater features carry nutrients and chemical signals across vast distances, connecting different vent and seep communities in a slow, patient network of underwater communication. Larvae from one vent community might drift for months before settling at another vent hundreds of miles away, creating genetic connections across the ocean basins and ensuring that these oases of life remain connected despite the vast distances between them. In these underwater gardens, time moves differently. Creatures live longer, grow more slowly, and build structures that persist for centuries. It's a different rhythm of life, one that values permanence over speed, patience over quick growth, and endurance over immediate success. These communities represent life's long-term thinking, creating beauty and abundance that will persist long after we ourselves have become part of the gentle rain of marine snow that feeds the deep ocean's endless patience. Chemosynthesis and hidden ecosystems, life's revolutionary discovery. For most of human history, we believed that all life on Earth ultimately depended on the sun. Every food chain we studied, every ecosystem we explored, could trace its energy back to photosynthesis, that gentle process by which plants capture sunlight and transform it into the chemical energy that feeds our world. It was a beautiful, simple truth that connected every living thing to our nearest star. Then, in 1977, scientists made a discovery so profound it revolutionized our understanding of life itself, revealing that our planet harbors entire civilizations of creatures that have never known the touch of sunlight. Deep beneath the Pacific Ocean, around volcanic vents where the Earth's crust meets the sea, researchers discovered something that shouldn't have existed according to everything we thought we knew about life. Thriving communities of bizarre creatures surrounded these underwater hot springs, not just surviving, but flourishing in conditions of total darkness, crushing pressure, and water laden with chemicals that would be toxic to most surface life. These creatures had discovered something extraordinary, a way to harvest energy directly from the Earth's chemistry, independent of the sun that has powered life for billions of years. This process, which scientists named chemosynthesis, works like a mirror image of photosynthesis. Instead of capturing light energy to convert carbon dioxide into organic compounds, certain bacteria capture the chemical energy stored in substances like hydrogen sulfide, methane, and ammonia. These chemicals, which bubble up from the Earth's interior through hydrothermal vents and cold seeps, become the foundation for entire ecosystems that exist in what we once thought was a biological desert. Imagine the profound implications of this discovery. Here were communities of life that had evolved completely separately from the sun-dependent world above, creating their own energy from the planet's geological processes. It was like finding a secret civilization that had developed its own technology, its own architecture, its own way of being alive, all hidden in the depths where no human had ever looked. The bacteria that perform chemosynthesis are microscopic master chemists, taking simple inorganic molecules and transforming them into complex organic compounds that can sustain life. They work with the patience and precision of ancient alchemists, but instead of trying to turn lead into gold, they turn the Earth's own exhalations into the building blocks of life. Some of these bacteria are free-living, forming thick mats that coat the rocks around vents like living carpets. Others have entered into the most intimate partnerships with larger creatures, living inside their tissues in relationships so close they've become essentially one organism. The giant tube worms that sway around hydrothermal vents represent perhaps the most beautiful example of this partnership. These remarkable creatures have no mouth, no stomach, no digestive system as we would recognize it. Instead, their bodies are filled with specialized organs called trophosome, which house billions of chemosynthetic bacteria. The worms provide their bacterial partners with hydrogen sulfide absorbed through their red feathery plumes, while the bacteria provide the worms with organic compounds that serve as food. It's a relationship so perfectly balanced that neither partner can survive without the other, a living testament to cooperation's power to create new forms of existence. This discovery has expanded our definition of where life can exist to almost unimaginable extremes. Scientists have now found chemosynthetic communities thriving at depths of over 31,000 feet in ocean trenches, deeper than Mount Everest is tall. These ecosystems exist under pressures that would instantly crush any surface creature, in temperatures that range from near freezing to boiling hot, in water so acidic it would dissolve metal. Yet life not only persists, but creates beauty and abundance. The implications extend far beyond our oceans. If life can thrive using chemosynthesis in the extreme conditions of deep-sea vents, it opens up possibilities for life in places we never thought to look. The subsurface oceans of Jupiter's moon Europa, the methane lakes of Saturn's moon Titan, the underground aquifers of Mars. All of these environments, once thought to be sterile, now represent potential havens for chemosynthetic life. Recent discoveries have revealed that these chemosynthetic ecosystems may be far more extensive than we ever imagined. Deep beneath the ocean floor, in networks of fractures and cavities within the rock itself, scientists have found evidence of vast microbial communities that may contain more biomass than all the life in the surface oceans combined. These subsurface ecosystems operate on geological timescales, with bacteria that might reproduce only once every 1,000 years, living in a slow-motion world where chemical reactions proceed with the patience of mountains. The energy flows in these chemosynthetic systems create their own unique rhythms and patterns. Unlike surface ecosystems, which pulse with the daily cycle of light and darkness, chemosynthetic communities follow the geological rhythms of the Earth itself. Volcanic activity might increase the flow of chemicals from vents, causing communities to bloom and flourish. When vents become inactive, communities must migrate or adapt, creating slow-motion ecological dramas that play out over decades or centuries. Perhaps most remarkably, scientists have discovered that some chemosynthetic organisms can use multiple different chemical energy sources, switching between them as conditions change. These metabolic shapeshifters represent life's ultimate adaptability, able to harvest energy from whatever chemicals are available. Some can even switch between chemosynthesis and other forms of metabolism, creating biological backup systems that ensure survival even when conditions change dramatically. The discovery of chemosynthesis has also revealed the incredible antiquity of these processes. Evidence suggests that chemosynthetic life may have been among the first forms of life on Earth, existing billions of years before photosynthesis evolved. These ancient chemical pathways may represent life's original energy source, making the chemosynthetic communities of the deep sea not just alternative ecosystems, but windows into life's earliest experiments with existence. In the gentle darkness of the deep ocean, where these remarkable communities thrive, we find a profound lesson about life's creativity and resilience. Here, in conditions that would seem utterly hostile to our surface-dwelling sensibilities, life has not just found a way to survive, it has found ways to create abundance, beauty, and complex ecological relationships that rival any terrestrial ecosystem. These hidden worlds remind us that life's ingenuity extends far beyond our ability to imagine it, and that even in the most unlikely places, the patient work of existence continues, creating new forms of wonder in the quiet depths of our planet's most mysterious realm. Survival strategies and mysteries. The art of thriving in Earth's final frontier. In the profound depths of our oceans, where the weight of water above could flatten a city bus and temperatures hover just above freezing, life has developed survival strategies so elegant and mysterious that many of them still puzzle scientists today. These are not desperate last-ditch efforts at mere existence, but refined arts perfected over millions of years, ways of living that transform the seemingly impossible into the beautifully inevitable. Consider the remarkable strategy of vertical migration, perhaps the greatest daily journey on our planet. Every evening as the sun sets on the surface world above, billions of deep-sea creatures begin a slow, patient ascent toward the upper waters. Lanternfish, krill, jellyfish, and countless other organisms rise from depths of over a mile to feed in the more productive waters closer to the surface. Then, as dawn approaches, they descend again into the safety of the deep, creating a living layer that moves up and down through the ocean like a gentle, breathing membrane. This migration represents the largest movement of biomass on Earth. Yet it happens in near complete silence and darkness, visible only to the most sensitive scientific instruments. The creatures time their journey with precision that would make a Swiss clockmaker envious, ascending just as the last light fades and descending before the first rays of dawn might expose them to visual predators. It's a dance choreographed by evolution, performed by billions of participants who have never seen each other, yet move together with perfect synchronization. The energy management strategies of deep-sea creatures reveal a different philosophy of existence entirely. While surface animals often live fast-paced lives of quick movements and rapid metabolism, deep-sea creatures have mastered the art of slow living. A deep-sea fish might remain motionless for hours or even days, conserving every calorie, moving only when necessary, and then with movements so efficient, they seem choreographed. Their hearts beat slowly, their breathing is measured, and their entire physiology operates like a precision instrument designed to extract maximum life from minimum energy. Some deep-sea creatures have developed what scientists call sit-and-wait predation strategies that border on meditation. The anglerfish hangs motionless in the water, its bioluminescent lure glowing patiently as it waits for prey to approach. This might seem passive, but it represents one of nature's most energy-efficient hunting strategies. Rather than chasing prey and expending precious calories, the anglerfish has learned to make prey come to it, turning hunting into a form of underwater mindfulness practice. The reproductive strategies of deep-sea creatures reveal some of nature's most creative solutions to the challenge of finding a mate in the vast darkness. In an environment where encountering another individual of your species might be a once-in-a-lifetime event, evolution has crafted some truly extraordinary approaches to ensuring species survival. Some deep-sea anglerfish have evolved extreme sexual dimorphism, where tiny males permanently fuse to the much larger females, becoming essentially living sperm banks. It's a strategy that guarantees reproductive success, but represents one of nature's most dramatic examples of commitment. Other species have developed elaborate chemical communication systems, releasing pheromones that can drift for miles through the still water, creating invisible trails that potential mates can follow like underwater perfume. Some creatures synchronize their reproductive cycles with rare events, like the seasonal blooms of marine snow, ensuring that their offspring will be born into times of relative abundance. The symbiotic relationships in the deep sea represent some of evolution's most creative partnerships. Beyond the well-known relationship between tube worms and chemosynthetic bacteria, the deep ocean is filled with creatures that have learned to live together in ways that surface dwellers rarely achieve. Some deep-sea fish carry their own personal lighting systems in the form of bioluminescent bacteria that live in specialized organs. The fish provides the bacteria with nutrients and a safe home, while the bacteria provide light for hunting, communication, and defense.
Perhaps most mysteriously, many deep-sea creatures possess adaptations that scientists still don't fully understand. Some fish have been found with proteins in their blood that remain liquid at temperatures well below the normal freezing point. Yet, the exact mechanism of how these biological antifreezes work remains partially mysterious. Other creatures seem to navigate across vast distances in the featureless abyss with precision that suggests they're using sensory systems we haven't fully identified, perhaps detecting magnetic fields, subtle chemical gradients, or pressure variations too subtle for our instruments to measure. The extremophile physiology of deep-sea creatures continues to reveal new mysteries. Some bacteria found around hydrothermal vents can survive temperatures that would instantly kill any other known life form, while others thrive in conditions so acidic they could dissolve metal. Scientists have discovered microorganisms that can repair their DNA faster than radiation can damage it, and others that can remain viable for millions of years in a state of suspended animation. Recent discoveries have revealed that some deep-sea creatures may possess forms of collective intelligence that we're only beginning to understand. Certain species of deep-sea jellies seem to coordinate their movements over vast distances, creating synchronized displays that suggest some form of communication we haven't yet decoded. Schools of deep-sea fish have been observed performing coordinated maneuvers that appear too complex to be explained by simple, following behaviors, hinting at more sophisticated forms of underwater communication. The thermal regulation strategies of creatures living near hydrothermal vents present ongoing puzzles. Some worms can live with one end of their body in water heated to hundreds of degrees, while the other end remains in near-freezing water. The physiological mechanisms that allow this kind of thermal gradient to exist within a single organism are still not fully understood, representing one of biology's most extreme examples of temperature adaptation. Perhaps most intriguingly, deep-sea creatures seem to age differently than surface animals. Some deep-sea fish show evidence of extreme longevity, with individual specimens estimated to be centuries old. The mechanisms behind this extended lifespan in such a challenging environment remain largely mysterious, though they may be related to the slow metabolisms and efficient energy use that characterize deep-sea life. The navigation abilities of deep-sea creatures across the seemingly featureless abyss continue to puzzle researchers. Some species undertake migrations that span thousands of miles through water that appears uniform to human senses, yet they arrive at specific locations with remarkable precision. Whether they're using subtle chemical cues, magnetic navigation, or sensory abilities we haven't discovered, remains one of the deep sea's enduring mysteries. In contemplating these survival strategies and mysteries, we find ourselves face to face with the humbling reality that even after decades of deep-sea research, we've likely discovered only a fraction of the adaptive strategies that evolution has crafted in the depths. Each new expedition, each new technology that allows us to probe deeper or observe more carefully, reveals new forms of life and new solutions to the challenges of existence that expand our understanding of what's possible in the patient, mysterious world beneath the waves. Calm reflections on a hidden world, the silent wisdom of the abyss. As we slowly ascend from our journey through the deep ocean's mysteries, rising like gentle bubbles through the layers of water that separate the abyss from our sunlit world, it's worth pausing to reflect on the profound lessons that emerge from this alien realm that lies beneath our feet. The deep sea, with its crushing pressures and eternal darkness, its strange creatures and impossible chemistry, offers us more than just scientific curiosity. It provides a different way of understanding what it means to be alive on this remarkable planet. In the silence of the deep ocean, where sound travels differently and time moves to rhythms measured in centuries rather than seasons, we discover a form of existence that operates by principles almost opposite to those that govern our surface world. Where we value speed, deep-sea creatures have perfected the art of patience. Where we seek brightness and stimulation, they have found beauty in darkness and subtlety. Where we often struggle against our environment, they have learned to work with forces that would seem impossible to overcome, turning crushing pressure into structural support and toxic chemicals into the foundation of life itself. The creatures of the abyss move through their three-dimensional world with a grace that seems almost meditative. A jellyfish pulsing slowly through the midnight zone, its translucent bell contracting and expanding in rhythm with some internal metronome, embodies a different relationship with time and space than anything we experience on land. There's no hurry in its movement, no waste in its motion, just the essential pulse of existence, reduced to its most elegant form. This underwater world spans distances that dwarf continents, yet remains largely unexplored. Scientists estimate that we've examined less than 5% of our ocean's depths, meaning that vast realms of our own planet remain as mysterious to us as distant galaxies. In an age when we can see the surfaces of planets orbiting other stars, the deepest parts of our own world remain largely invisible, populated by creatures we've never seen, governed by processes we don't yet understand. The bioluminescence that illuminates the deep ocean carries its own gentle philosophy. These creatures create light not to conquer darkness, but to communicate within it, to find each other across vast distances, to create moments of beauty that serve essential functions. Their light is efficient, purposeful, and beautiful, never harsh or wasteful, always perfectly calibrated to its function. It's light that enhances darkness, rather than eliminating it, creating a kind of illumination that works in harmony with the environment rather than against it. As we reflect on the deep sea's hidden ecosystems, we're reminded that our planet is far more complex and wonderful than our daily experience might suggest. Beneath the familiar world of sunshine and seasons, soil and sky, lies another world equally rich, equally diverse, operating by different rules, but achieving the same fundamental goal: the continuation and celebration of life in all its myriad forms. The deep ocean's lesson about resilience resonates particularly strongly in our current moment. These creatures have survived ice ages and warm periods, mass extinctions and periods of abundance, always adapting, always finding new ways to thrive. They remind us that life's greatest strength lies not in avoiding change, but in learning to dance with it, finding opportunity in challenge and stability in adaptation. The silence of the deep sea, broken only by the occasional whale song or the subtle sounds of creatures moving through water, offers its own form of peace. In a world increasingly filled with noise and distraction, there's something profoundly calming about imagining these vast, quiet spaces where life proceeds at its own pace, undisturbed by the urgency that characterizes so much of surface existence. Perhaps most importantly, the deep sea reminds us that there are still mysteries in our world, still frontiers to explore, still questions to ask and wonders to discover.
In an age when it can sometimes feel like everything has been mapped and measured, the deep ocean stands as a reminder that our planet still holds secrets, still has stories to tell, still has the power to surprise and amaze us. As we surface from our imaginary journey through the depths, carrying with us images of glowing creatures and impossible partnerships, of patient survival and elegant adaptation, we might find ourselves seeing our own world with slightly different eyes. The deep sea's lessons about patience, cooperation, efficiency and resilience are not confined to the abyss. They're principles that can enrich any life, in any environment, reminding us that sometimes the most profound wisdom comes from the quietest places, and that the most beautiful solutions often emerge from the deepest challenges.